What's up everyone, my name is Chemist. Welcome to this channel where we make chemistry easy for your understanding. And if that sounds good to you, click that subscribe button below and hit on the notification bell in order not to miss any of our video. Thank you. In this video, we're going to talk about assignment of oxidation numbers. And in order to assign an oxidation number to an atom in a molecule, we need to follow some set of rules. Now, number 1, the oxidation number of all elements in their uncombined form is 0. Therefore, the elements in H2, F2, Li, O2, P4 and S8 all have oxidation number 0 because they exist in uncombined form. 2. The oxidation number of monoatomic ions is equal to the charge on that ion. Therefore, Na plus, F minus and S2 minus have +1, -1 and -2 oxidation numbers respectively. 3. The oxidation number of oxygen in most compounds is -2, but it usually has an oxidation number of -1 in peroxides. Now, examples of peroxides are H2O2, that is hydrogen peroxide, and K2O2, potassium peroxide. Oxygen has an oxidation number of -1 in this peroxide. 4. The oxidation number of hydrogen is +1 except when it is bonded to a metal to form hydride, e.g. sodium hydride and calcium hydride, where its oxidation number is -1. So, hydrogen usually has an oxidation number of -1 in hydrides. 5. The oxidation number of all alkali metals, that is lithium, sodium, potassium and rubidium, is usually +1, while that of all alkaline earth metals, that is beryllium, magnesium, calcium, barium, is usually +2. 6. Fluorine has an oxidation number of -1 in all compounds, and the reason is that fluorine is the most electronegative element, so it always has an oxidation number of -1 in all compounds. 7. In a neutral molecule, the sum of the oxidation numbers of all the atoms must be 0 because the molecule is neutral. Then the last rule says, in an ion which has more than one type of atom, the sum of the oxidation numbers of all the atoms is equal to the net charge on that ion. Now, let's use these rules to find the oxidation number of some atoms in some molecules. Now, let's try this first example. Find the oxidation number of chromium in Na2Cr2O7. Now, we are going to be using the rules to find the oxidation number of chromium here. Now, we have Na2Cr2O7. And now the first question is that this compound, does it has any charge? No. Looking at it, it is a neutral compound. It has no charge. And rule 7 says, in a neutral molecule, the sum of the oxidation numbers of all the atoms must be equal to what? 0. So, which means that when we add the oxidation numbers of these 3 atoms, it must be equal to 0. Then, remember that we said the oxidation number of all alkali metals is +1. So, the oxidation number of sodium will be +1. Then we have 2 atoms of sodium multiplied by 2, put it in bracket. We are looking for the oxidation number of chromium, but we have 2 atoms of chromium, so we are going to make that 2Cr, then plus. Remember that the oxidation number of oxygen is usually what? -2, except in peroxide. But now we are not having peroxide, so we are going to use -2. Then how many atoms of oxygen do we have? 7. Multiplied by 7, then everything is equal to 0. Plus 1 times 2, that will give us +2. plus 2Cr plus minus 2 times 7, that's minus 14, is equal to 0. Now, we can now collect like terms. 2Cr plus 2 plus times minus is minus, so this will become minus 14 is equal to 0. 2Cr plus 2 minus 14, that's minus 12, is equal to 0. 2Cr will now be equal to what? 0 plus 12, and 2Cr will now give us plus 12. Now, what are we going to do here? Divide both sides by 2. Divide both sides by 2 in order to get the value of our Cr. So 2Cr divided by 2 will be equal to plus 12 divided by 2. Then 2 will cancel 2 here. 2 here 1, 2 here 6. So Cr will be equal to what? Plus 6. Which means that the oxidation number of chromium in Na2Cl2O7 is plus 6. Yes, now let's try this second example. Find the oxidation number of manganese in MnO4-. Now, the compound given is MnO4-. Now, the first question is that, does this compound has a charge? Yes. How many charges do we have here? We have a charge of -1, a net charge of -1. So this is an ion, and it's an anion because it has a negative net charge. So now remember that rule 8 says that in an ion which has more than one type of atom, the sum of the oxidation numbers of all the atoms is equal to the net charge on the ion. So we are going to have, since we are looking for the oxidation number of manganese, we are going to have Mn that we are looking for plus, what is the oxidation number of oxygen? Remember that it is -2. -2 multiplied by how many atoms of oxygen do we have here? 4, will be equal to the net charge here, which is -1. So we are now going to have Mn plus -2 times 4, that's -8. Everything is equal to -1. So open the bracket. Mn plus times -8 is equal to -1. So we can now collect like terms. Mn will be equal to -1 plus 8. Then Mn will be equal to -1 plus 8, that is plus 7. Which means that the oxidation number of manganese in MnO4- is what? Plus 7. Okay, so let's try this third example. Find the oxidation number of aluminium in LiAlH4. Now, the compound given is LiAlH4, and we have lithium, aluminum, and hydrogen. Now, remember that because this compound is neutral, it has no charge, the sum of the oxidation number will be 0. So, which means that the sum will be equal to 0. Now, remember that lithium is an alkali metal, and the oxidation number of all alkali metals is usually +1. So we are going to have +1 plus the aluminium we are looking for, plus, now hydrogen here is in form of hydride. Why? Because it is combining with metal, and remember that the rule says when hydrogen is combining with metal in form of hydride, it has an oxidation number of -1. So we are going to have -1 multiplied by 4 atoms of hydrogen. Everything is equal to 0. Plus 1 plus Al plus -1 times 4, that's -4, is equal to 0. Now we can open the bracket. Plus 1 plus Al minus 4 is equal to 0. Now let's collect like terms. Al plus 1 minus 4 is equal to 0. Al plus 1 minus 4, that will be -3, is equal to 0. Now, so definitely Al will be equal to what?
0 plus 3, then Al will be equal to plus 3, which means the oxidation number of aluminum in this compound is plus 3.
If you enjoyed this video, click on the subscribe button below and join our chemistry family. Thank you once again. Goodbye.